Hi, this is Dr. Vahid Aryadust here, and in this video I'm going to illustrate how to do a two-step clustering analysis. The data that I'm going to use is from a core 2016 research project whose principal investigator is Dr. Melvin Chen. I'm the co-principal investigator in this project, so I'm using this. The project is sponsored by the National Institute of Education of Nanyang Technological University, and the data that I'm using is just a partial adaptation of the data that has been collected. I have variables like grammar, vocabulary, comprehension scores, writing scores, and the total score, which is calculated based on these and other scores which are not available in this analysis. Sorry, it's just computed based on these scores, so everything is available. The other thing is that I have missing data in some of the variables, which is represented by -999, as you can see here. For clustering, we need to remember that there are two assumptions, one being normality and the other one being the independence of variables. For both of these, I have created videos in the past. I suggest that you watch those videos if you haven't watched them. I'll leave the links in the comments or the description area of the video below it. Okay, for clustering analysis, you need to go to Analyze. Under Classify, you'll see there are a bunch of options here. Today we just talk about the two-step clustering. Click on this and you'll get this menu. We do clustering because we want to reveal natural groupings or clusters, so it confers an advantage over other techniques such as median split or perhaps even conjectures of scholars or researchers. So we need to do clustering to find out where we can draw lines between people and put them into different clusters based on what the algorithm outputs for us. As you see, we've got categorical variables and continuous variables. One of the interesting things about two-step clustering is that you can use both of these types of variables in your analysis. For the time being, I'm going to move grammar, vocabulary, comprehension, and situational writing score to the continuous variables. And I already assume that they are normally distributed. I have talked about this in previous videos, as I mentioned. In addition to that, I would like to see the effect of gender on our clustering. So I'm going to move gender to the clusterings. So if I get 3 or 2 clusters or more, I want to see if gender plays an important role in the profile of those people who have been clustered in those models. Okay, before I move this to the categorical variable, just move it back, I want to say something about the distance measures. These are two ways of doing your cluster analysis. The log likelihood, which I prefer in almost every circumstance, unless I have a categorical variable, places a probability distribution on the variables. Therefore, if you're choosing this, make sure that the data is normally distributed. It assumes that your continuous variables are normally distributed, but also assumes that categorical variables like gender are multinomial. So if I move this gender to the right-hand side under the category variable box, the Euclidean distance measure will not be active anymore, as you see, because the Euclidean distance is not suitable for clustering of categorical variables. The Euclidean distance method is used whenever you want to have a straight line between the two clusters. So you don't assume normality under Euclidean. So I'm going to choose log likelihood and choose gender as another categorical variable. Now we have the number of clusters which can be determined automatically. I like this option because you don't have to run one cluster at a time, so it can run everything for you. I think 15 will be too many really, because it will be difficult to make sense of 15 variables. So I'm going to choose 10, a maximum of 10 clusters, and so I'm going to get options that have got 1 up to 10 clusters, and their fit statistics here will be compared with each other, and the best one of those models will be chosen by SPSS. This is another good thing about this kind of clustering. There are two types of fit statistics, or as SPSS calls them, clustering criteria: Schwarz-Bayesian information, or otherwise we know it as Bayesian information criterion, which is used in a wide range of supervised and non-supervised techniques. Non-supervised techniques are basically clustering techniques, and supervised are pretty much similar to regression, and they have a huge family, and they include neural networks, artificial neural networks, regressions, and so on. Akaike information criteria, or AIC for short, is another one. Now, there is some literature that suggests that we should use BIC. There's some literature that suggests that we should use AIC. For this presentation, I'm going to use BIC because, at least in structural equation modeling, it's been shown to be rigorous. Under options, we have outlier treatment. I don't want to do any outlier treatments, but if you feel you have outliers, you can choose use noise handling and leave this as 25%. So if there's any outlier, it will be handled and will be replaced with some statistics in the analysis. For memory allocation, the maximum that I can do is 64. Basically, for conventional or usual computers like that of mine, we can choose anything between 4 and 64. But if you're having a super fast computer, something like, you know, those that's coming out of a sci-fi, which has got a lot more memory, well, you might want to choose more memory allocation. But for an analysis of 4 variables, I don't think that you need a lot of memory allocations. We need to standardize continuous variables. I highly recommend that. So everything has already been chosen for us, but if you think that one of your variables is already standardized, you can move it to this box. But I don't have any standardized variables for the time being, so I leave everything untouched. For advanced, I think it's a good idea just to leave it as is. Research shows that the maximum branches to be left at 8 and the maximum tree depth to be left at 3 is a very good option. For cluster model updates, we can import clustering solution trees from a previous analysis. We would choose this option only if we want to import and update a cluster model that was generated in a prior analysis. We do not have that, so we just leave it as is and leave the number of nodes possible to the default. I suggest that, and continue. For outputs, it's actually straightforward. You can get the pivot tables. It's not a very bad idea really to get pivot tables, and charts and tables in model viewer has already been chosen. This is important for us because it gives a lot of information about the statistics that we have. Now, if you want to use another variable after the clustering analysis has been carried out to kind of see if it can predict your clusters, this is where you can do that. So you can move this to the evaluation fields. So I want to stress that these variables will not be used in clustering, but it's going to be a kind of post hoc analysis. After the clustering is done, let's say you've got 3 or 2 clusters, then you can get a distribution of this variable across your clusters as well, or this variable. I don't need that for this analysis, so I leave this empty, but feel free to do that. It will not affect the results of your clustering at all. Finally, we've got creating cluster membership variables, it's important. I recommend that you click on this to choose it and click continue, and everything is ready now. Just click OK. And here is the result of our analysis. The first thing that we should look at is the BIC, in the BIC change. So let's look at BIC first. I'm going to double click on this column and highlight everything. What we want to do is to minimize BIC. So I right click on this and I'll go to create graphs. I want to visualize BIC for myself and then click on line. Then you'll get a line graph here, something like a scree plot, which I discussed in another video. So the highest BIC is the one that belongs to a one cluster solution. The second highest one is number 2, and we have a little bit of elbow here. And for 3 and 4, there is also a dip. But as to whether this this decrease of BIC from a 2 cluster model to a 3 cluster model is significant or not, well, we cannot say just by looking at this graph. But we know that somewhere around 2 and 3 cluster, there should be a good sort of solution. Okay, then the BIC change is also useful to look at. I'm going to double click, I'm going to highlight this, right click, create graph, and create a line graph to visualize this. As you see, the BIC model, the BIC change from 2 to 3 is significant, but after 3 is not that much considerable. So I think it could be something again in this neighborhood, maybe a 2 cluster model. What we can do is to scroll down and look at the solution which has been chosen for us by SPSS, and that's a 2 cluster model. Yes. So we can stick with this 2 cluster model. I'll go back to this chart later. Let's look at the distribution of the 2 clusters. For the first cluster, we've got 902 people. For the second one, we've got 869. I have some missing data, as I showed you before. So 1,771 cases have been used in clustering analysis, whereas the sample size is 1,896 people. And if everything had been used in clustering, this percentage of combined and percentage of total would have been the same, but they're not identical since I've got missing data. So for the first cluster, I have 47% of people. For the second one, according to the percentage of total, and for the second cluster, I have got 45.8% of people. I don't know if I read the first one correctly, but if I didn't, so it's 47.6%. Okay. Not too bad. The distribution is fine, I would say. It's hovering around 50%, which is not too bad. So the ratio of the first and the second cluster should not be too large, and I will show that in a second to you. We can calculate that ratio. So cluster profiles, under cluster profiles, we look at the centroids. It's a useful chart in which we see for cluster 1, the mean score of cluster 1 under grammar score is 9.75, whereas the mean score for cluster 2 is 9.11. So the mean scores of the first cluster are larger than the mean scores of the second cluster in each of those indicators. The standard deviations are also provided. That's a good thing. And if you run a t-test, which I will show you later, you will see that these differences are statistically significant. In other words, SPSS has created this natural grouping or clustering for us based on the scores of all of these categories or all of these indicators. Okay, what you could do is to move these to an Excel sheet, which I've already done, and create create a chart like this. Well, this table, this graph is somewhat, the statistics are somewhat different from the ones that you see here. It's because I ran an analysis on a separate data set, but the principle is the same. You just copy and paste the output, the centroid, into this and into Excel sheet, and then move the mean scores of clusters 1 and 2 to another section which you can create, highlight everything, go to insert, and click on any of these graphs that you like. I've chosen this graph, but if you like, you could also choose, for example, line graph, which also shows you how different clusters 1 and 2 are. Like I said, these differences between the two clusters across each of the indicators are statistically significant, as I'll show you later. Okay, now for gender, very interestingly, for cluster 1, there is no frequency of males. There are no males. Everybody in cluster 1 is female. But on the other hand, for cluster 2, everybody is male, whereas there is no male in cluster 2. That's a very interesting, there's no female in cluster 2. That's a very interesting phenomenon. Now, this model summary is very important, but you cannot see much here. You need to double click so this chart will appear. We've got a silhouette measure of cohesion and separation. Cohesion, or tightness, and separation are important statistics in clustering. Cohesion or tightness refers to how similar or how close the cases in each cluster are with each other. So if the cases are not very similar, you will not have a very high cohesion. On the other hand, separation is how far the clusters are, how dissimilar the clusters are from each other. Now, there are no hard and fast rules to make sense of the silhouette index. But what I can tell you is that if the silhouette index is below 0, because it ranges from -1 to +1, if it's below 0, then we are in trouble, which means that our clustering is wrong. But if it's above 0, it's fine. The closer it gets to 1, the better it is. SPSS assumes that if it's larger than 0.5, it's good. If it's between maybe 0.2, I'm not sure what that borderline is, honestly, but 0.2 to 0.5, it's fair, and below that is poor. In my opinion, the closer you get to 1, the better it is. Of course, if you have got anything above 0.5, you'll be happier than if you get something around 0.4. So like I said, there are no fixed or definite rules here. But just make sure that your silhouette index is not 0, and is not negative. That's the first point. On the other hand, you've got the cluster size on the right-hand side. 50.9% of people have fallen in cluster 1, represented by blue color, and 49.1% of people are in cluster 2. And here's the ratio of sizes, as I mentioned before. The ratio of the large to the small cluster should be less than 3, and ideally less than 2. Actually, it's around 1, which is really a good ratio. 1 is the best thing, because it means 50% of people have fallen in one cluster and 50% in another cluster. Now this ratio changes as you get a larger number of clusters. Now under this side, the left hand side, you see this tab. You can click on clusters, and you'll get the distribution of clusters as well as their inputs. For cluster 1, which has got 50.9% of people in it, this is the mean score of oh, okay, sorry, this is females. They don't have a mean score. If 100% of people clustered in number 1 are female, whereas 100% of people are in cluster 2 are males. We have already seen that. Now for situational writing, you can see the mean scores for all the variables. Actually, you can see the mean scores across the 2 variables. Now I click on number 1, so it will be highlighted, and this is a cool thing. This is another visual representation of the 2 clusters. You can just ignore males and females because everybody in this cluster is female, 100%. There's no one under males, 0. These boxes are basically box plots. In another video, I have discussed how to make sense of box plots. The line, as you remember, in box plots represent the median. So the median of the first variable, the situational writing total score, that's the writing score, is 13.4. This is regardless of the cluster. And for the median of the first cluster, we see it has reached 14.95, which is much larger than the median of the variable itself, regardless of clustering, which indicates that this group has a higher performance compared to the second group. I'm going to click on 2, as you see, which whose median falls below the median of the variable with 11.0.5. Now, if you like to display the medians of both clusters, you can just hit cluster and keep it, and then click on 1 as well. So you'll get both clusters. The median for cluster 2 is 11.0.5, whereas that for cluster 1 is 14.95. And these are the colors for clusters 1 and 2. In the same way, for vocabulary, you see that the median of cluster 2 and the median of the variable are somehow close to each other, and the median for cluster 1 is larger. In all variables, without any exception, the median of the first cluster is larger than that of the second clusters, as you see here. The difference is smaller when it comes to the comprehension score, but it's still statistically significant. We can check that. You can choose other options. Let me just click on this. For example, if you click on this variable, it will show basic information, as I have talked about before. And if you choose this, it will show you, okay, encounter some problems and will not be shown. Okay, sorry, I think it might be a problem with my computer. But anyway, so yeah, I'm going back to the original data. If you click on these cells, the distribution will be visualized here. This is for genders, but if you click, this is a cooler kind of distribution for situational writing. The background, the kind of shady area you see in the background, is the entire sample that we got. This one is a distribution of people's scores for cluster 1. This one is for cluster 2. You can compare that. You just toggle between the two, and you see that it moves. There is, even visually, there is a significant difference between them. For vocabulary, we have a different story. This is for cluster 1, highest score. This is for cluster 2, lower score. Cluster 1, cluster 2, cluster. Okay, this is kind of strange looking. It reminds me of the scales on the back of dragons. And this is for cluster 2. See, the spikes are higher for comprehension scores in cluster 1, but they're lower spikes for cluster 2. Anyway, so even visually we can confirm that there is a significant difference between the two groups. I think you can also toggle across these. You can arrange these clusters based on their sample, the size, which is already like that. If you have a large number of clusters, sometimes they're not arranged based on their size, sometimes they're arranged based on the number of clusters, etc. So you can actually do different sorts of arrangement based using these. Anytime you feel lost in the analysis and you don't know how to get back, you also just hit the the reset button, and you will get back to where you started. Then this is all we should know about the clustering. And one last thing is, before I close it, we need to look at this TSC variable, which has been created for us. Two-step clustering. So since we've got missing variables, these clustering are not estimated. And so that's the reason why this is not estimated. For some other reasons, the clustering for these variables has not been estimated either. But as you see, the clustering for these guys is there. So we can highlight this. These guys have fallen into cluster 2, and there must be some people who have fallen into the first cluster. Yes, so if you scroll down, you see that some people have fallen into the first cluster. Okay, and now you can use this as an independent variable to run usual t-tests. So I would like to just go to compare means. I have created videos on running independent samples t-tests. I don't go through the assumptions and all that. Let me just reset this. I would like to move these 4 variables to the right hand side on the test variables, because I want to run a t-test based on the clustering that was just generated. So define clustering 1 and 2. Please watch the videos if you're not sure what I'm doing here. I've made quite a few videos about t-test and also ANOVA. If you have a large number of clusters, for example 3 clusters, then you should use an ANOVA test. I would also like to move English total score to the test variables, because I want to see if the English total score is also significant across the 2 clusters, even though I didn't include it in the clustering option. So these 5 variables should be fine. Click OK and see if the differences are significant. Yes, every difference except for the comprehension score is statistically significant. It's interesting because in a previous analysis which I was testing, I didn't include gender, and there was a significant difference between the 2 clusters in comprehension scores. So I want to quickly go back to the clustering analysis and remove gender to see if I can get back the results that I had obtained before. We still have 2 clusters, and the silhouette is more or less the same, as you can see. What I would like to do here is to go back to this analysis. Okay, now the results of this analysis. Now what I would like to add is that we couldn't see the clustering for these guys because gender was in the analysis, and gender, as you see, is missing for these. So if you have a missing value in any of the variables, the clustering will not be estimated for those variables, for those cases in the variables. Now for the TSC without gender, things change quite a little bit, but not too much, as you see. As you see that there are some differences. You can run a chi-square test to see if the differences are significant. I would like to go back to my t-test analysis here and run a t-test to see if, oh, the comprehension score still remains insignificant. That's interesting. So I might have done something different. Anyway, so I think the whole idea is this. You run a 2-step analysis, you find the best model, and then you can run t-test or ANOVA, depending on the number of your clusters, as a post hoc analysis to figure out whether the differences between the two groups are significant or not. If it's not significant, like this, what I would suggest is that you can run a follow-up analysis, a cluster analysis, and leave out that variable, which is comprehension, and just click OK and get a new clustering, which is still a two cluster sort of analysis. I think there is one last thing that I really need to talk about before I close this video, and that's the idea of predictor importance. I'm clicking this. As you see, in the last analysis I had three variables, and these are the importance statistics of them. Importance statistics ranges from 0 to 1. You can also convert it into percentage, and it indicates whether the variable contributed to clustering, and if so, how much. So it's 100% was important in clustering. For this one, it was 75%. The vocabulary score was 75%, and the situational writing score was 40%. Again, there are no definite rules how to interpret importance variables, but I would say if something is not very important, if it's around 1% or 2%, I would just leave it outside of the analysis. Another way of looking at this is that if you have a variable which has a low significance, if you run a t-test, you would be better off to leave it out if the t-test is not statistically significant, like I did for the comprehension score. So you can combine different pieces of evidence from different analyses to decide whether to keep that variable in your analysis or not. Okay, thank you very much for paying attention to this video. I think I should just close this video. It's been half an hour. If you have stayed with me, thanks. And since we are getting closer to the Christmas season and also the end of the year and the 2020, I wish you a wonderful new start to 2021. And I also hope that COVID-19 will be blown over in 2020. Have a good day.